Evening, everyone. My name is Nagarjun Nimmalwar. My entry number is 2018 ME20694, and my project topic is front suspension arrangements. So let's first know what is suspension system and what it actually does and why do we need it. Suspension is a term given to the suspension system of springs, shock absorbers, and linkages that connect a vehicle to its wheels. It serves a dual purpose, like contributing to the handling of the car and also to its braking. It protects the vehicle itself and cargo or the luggage from the damage and the wear which it endures during its journey. So the purpose of suspension system is to support the weight of the car, provide a smooth allow rapid cornering without extreme body roll, and firm contact with the road. Also allows front wheels to turn side to side for steering. Works with the steering system to keep the wheel in contact, correct alignment. Passenger and cargo from vibration and shock. So these are some of the basic parts of the suspension system. Control arm, which is a movable lever that fastens the steering knuckle to the vehicle's body frame. Steering, and then there is steering knuckle, which provides a spindle or bearing support for the wheel hub, bearing, and the wheel assembly. And the pictures are at the side. And then there is the ball joints, swivel joints that allow control arm and steering knuckle to move up and down and side to side. And there are springs which suppose the weight of the vehicle, permits the control arm and vehicle to move up and down. Then there are shock absorbers, also known as dampers, keep the suspension from continuing to bounce after spring compression and extension. And there are control arm sleeves that allow the control arm to swing up and down on the frame. Then there are two types of suspension. Non-independent suspension. It has both right and left wheel attached to the same solid axle. When one wheel hits a bump in the road, its upward movement causes a slight tilt of the other wheel. And then there is independent suspension. Independent suspension is a broad term for any automobile suspension system that allows each wheel on the same axle to move vertically independently from each other. So as I explained before, the upper one is the non-independent suspension. As you can see here, when the wheel hits a bump, the other side of the car tilts a bit downwards. But in the case of independent suspension, when the car hits a bump, the other side stays where it is. Only the side which is going over the bump moves up. So now we'll talk about the front suspension. There are two major types of conventional front suspension, and they as I discussed before, they are independent, and dependent. The dependent front suspension uses a solid axle. The design consists of a one steel rod or aluminum beam extending the width of the vehicle. This beam is held in place by the leaf springs. This design also uses kingpins and bushings to attach the wheel outboard of the axle. Because of its load carrying ability, the solid axle is only used on trucks and the heavy off-road vehicles, and it is not suitable for the modern passenger cars due to these three important reasons. Transfer of which are the transfer of road shock. There is a transfer of road shock from one wheel to other due to the way the wheels are connected to the axle, as we have seen in the picture before. And unsprung weight, because of the solid axle has a lot of unsprung weight, it needs more spring and shock control to keep the tires in contact with the road. And then there is wheel alignment. The solid axle design makes no provisions for alignment. Then let's discuss the types of independent front suspension system. This system is also known as the parallelogram type suspension system. This is because of the upper arm, lower arm, and the stub axle form a shape of a parallelogram when they are connected. It consists of an upper arm, lower arm, which attaches to the stub axle carrier or steering knuckle. The first type is the coil spring type 1. This design uses coil springs which provide springing action to the suspension. The spring sits between the upper and the lower arm The lower arm attaches to the frame at at a single point. Then there is coiled spring type 2. This is the most common design, which also uses coil springs. The spring sits between the upper and the lower arm. However, here the lower arm attaches to the frame at 2 points, unlike the type 1 spring type. Then there is coil spring type 3. In the third type, the coil sits between the upper and the spring tower or the housing, which is the part of the vehicle, as you can see in the picture below. Then there is the torsion bar. The torsion bar connects to the upper or the lower control arm at the end, and at the other end, it connects to the frame. It can be mounted longitudinally, front to rear, or transversely. As you can see in the picture, how it has mounted in longitudinally, and in the other picture, you can see it has been mounted transversely. Unlike coil spring and leaf springs, torsion band can be used to adjust suspension ride heights. As we have discussed, then there is a leaf spring. This design uses leaf spring in place of coil springs, as we have seen before, for springing action of the suspension. One end of the leaf spring attaches to the chassis frame, while the other end attaches to the arm, as you can see in the picture here. Then there is McPherson strut. This design uses a special unit consisting of spring and shock absorbers. It was named after McPherson, who invented it, and hence the name. The manufacturer uses this design particularly in monocoque body constructions. The picture below you can see that. Then there is double wishbone. The double wishbone is another type of strut suspension that is becoming more common these days. It combines the space-saving benefits of a strut suspension system with the ability of a parallel arm suspension to ride low to the ground. This allows for a more aerodynamic hoodline. You can see below the picture of the double wishbone suspension. Thank you.